Okay, hi everybody. Last week we finished the sine law. We knew that when we used the sine law to solve for a triangle, we needed to have an angle and its opposite side, like angle A, side length A. I can't use the sine law here. Here I'm giving an angle, but I'm not giving its opposite side. I'm giving something called two sides, 11 here and 21 here, and the contained angle. So the two sides come together, they make an angle here, two sides of the contained angle. So I can't use the sine law, but I can use something called the cosine law. Now the cosine law goes something like this. It starts like the Pythagorean theorem. A squared equals b squared plus c squared. But then we're going to add a little bit more to it. Minus 2 times little b times little c times the cosine of angle big A. Excuse me. They always seem to give us three formulas, but the formula is always the same. If I have the lowercase side on one side, I'm going to have the capital letter for the angle on the other side. So for instance, if I want to find the side length little b squared, that's going to equal little a squared plus little c squared minus 2 times little a times little c times the cosine of angle B. And I'll let you figure out, if I want to find little c squared, what I'd have on this side. Now, for example, let's see if we can finish this one up here. We'll use this formula here. We'll just simply, I want to find the side length of little a. So I'll substitute, we want to find little a. Little a squared equals, little b squared, so that's 11 squared, plus little c squared, 21 squared, minus 2 times b, c, 11 times 21 times the cosine of angle A. That's 81 degrees. The cosine of 81 degrees. Okay, we'll simplify this down. Using BEDMAS, 11 squared, that's 121, plus 21 squared, that's 441, minus 2 times 11 times 21, that works out to 462, and then we can take our calculator, cosine 81 degrees, and that works out to 0.1564. Now you could hit pause and finish this up and then check your answer at the end. Okay, we'll simplify this. BEDMAS. We do our multiplication before we do our addition and subtraction. A squared equals 121 plus 441 minus, what's 462 times 0.1564? That works out to about 72.3. Now we'll do our addition and subtraction. A squared equals 121 plus 441 minus 72.3 is approximately 489.7. We've simplified all this down to 489.7. A squared, little a squared equals that. Now how do I get rid of this exponent? I'll take the square root of both sides. Square root of a squared is a. And the square root of 489.7 is approximately equal to 22.1. Little a is approximately equal to 22.1 units. 22.1 units. Okay, now if I want to figure out the rest of these angles here, angle B and angle C, I can use the sine law now. We can go to the sine law. We have an angle and its opposite side and the other two sides. All right? You guys, after finishing seeing this, you should try page 496, number 5A. Another time you can use the cosine law is if you're given all three sides. We're not given any angles, but we're given all three sides here. Side length little a is 14, side length little b is 9, side length little c is 6. Excuse me. Well, I can find angle a using this formula. If I have little a on one side, I'll have cosine a on the other side. Fill the numbers in here. 14, little a is 14 squared. 14 squared here. B is 9, so we have 9 squared. C is 6, so we have 6. Minus 2 times b times c, or 9 times 6 times the cosine of a. Now this is a little more of a complicated calculation, but we can work through it. 14 squared, that's 196, equals 9 squared, that's 81. 6 squared, that's 36, minus 2 times 9 times 6, that's 108 times the cosine of angle A. Okay, we're just going to have to solve for cosine A. All right, we can add these two numbers together. 81 plus 36, 196 equals 117 minus 108 times the cosine of angle A. We can't combine these. That's 108 times the cosine of A. Okay, we can't combine these, but we're going to solve here. If I subtract 117 from both sides, I end up with 79 on the left side and negative 108 times the cosine of angle A on the right. Now how do I get rid of this negative 108? This says negative 108 times the cosine of angle A. Well, I'll divide both sides by negative 108. And that's going to leave me with, they'll cancel out, this leaves me with cosine of angle A here, and 76 divided by negative 108, that is negative 0.7315. Good, now I've solved for cosine A. We can use second function cosine on your calculator, and we find out that angle A works out to 137 degrees. 137 degrees. That's what I've got here. Angle A, 137 degrees. We solve for the rest of the triangle using the sine law. Now I have an angle, its opposite side, and another side. We could find little b. We could find capital B, angle B over here. If I know side length little c, I can use capital C. Use the sine law from this point forward. Once you get an angle on its opposite side, continue on with the sine law. You guys should try page 497, number 5D right now. Okay, I wanted to give you an idea of how to approach number 10 on page 500. The information there says in triangle ABC, BC is twice the length of AB, angle B is 120 degrees, and angle AC, or side length AC, is 14 centimeters. Determine the exact lengths of AB and BC. So I kind of set it up this way. Drew this triangle ABC. It said that angle B was 120 degrees. So I drew it to scale. It's not exact, but I have a pretty good sketch here, 120 degrees. It also said that the length of AB, excuse me, the length of BC is twice the length of AB. So I drew it like that. AB is about half the length of BC. And it also said that length AC is 14 units long. So let's label this out, kind of help us out when we use the cosine law. All we're given is an angle and its opposite side. We're not given anything else. We'll call that side length little b. We'll call this side length little a. We'll call this side length. You know what? Let's represent this differently. Since this side length BC is twice the length of AB, let's use another variable to represent. If I let x represent the length from A to B, well, I can represent B to C as twice x, or 2x. I have expressions to represent this length and the contained angle. We can set this up to solve for x. I'll get you started here. We know that 14 squared is equal to that side squared, we'll call it x squared, plus that side squared, 2x in brackets squared, minus 2 times x times 2x times the cosine of 120 degrees. I'll let you work through that and then check the answer key. But that was just an idea of how to get you started on this one. Represent, because this side length is twice the length of this side length, we represented them using a known variable. Now another one you can take a look at. Let's see if we can move the camera so you can see it better. All right. This is number 11. Number 11 describes three circles that have radius of 3, 4, and 5, and they all touch each other. So we can do this. We have a smaller circle, a medium, and a large. So the radius, 3 here and 3 here. Radius here. What do we have? What did I have here? I have, I'll make this one 5, and this one 5, and this one 4, and this is 4. We've made her, when we connect up the centers of the excuse me, the circles, we can form a triangle. This side is 7 units long, or 8 units long. This side is 9 units long. This side is 7 units long. Not terribly drawn to scale, but we've got an appreciation. We have all 3 sides. So we can find all 3 angles using the cosine law. It asks you to find the area. The area of a circle, of a triangle, is base times height divided by 2. Well, we've got a base here. We can use the cosine law to find this angle here. But what about the height? The height, if I drop a line from here down, perpendicular to the horizontal side, we can call that the height. Well, how can I find it? Hey, I form myself a right triangle. And once you find this angle, you can use sine. We'll call it angle A. We know that the sine of angle A is equal to the opposite side, height, divided by the hypotenuse, 8. Once you find angle A, you can find the height. The base is 9. Once you find the height divided by 2, you should be able to get the area.